Hi, this is a 3D scan of engine airbox filter, and it was sent to me by a viewer from this channel. So in this video, I will reverse this part using Autodesk Inventor, and I will make it suitable for 3D printing. And then I will print out this part with ABS filament just to see the quality of the print and feel the strength of the part. The viewer used Creality scan Raptor, the original one, to scan this part, and he scanned the outer shell and the inner shell in one go without merging, because most automotive parts are thin shell. And if you scan outer shell and inner shell separately, sometimes you won't be able to merge because the shell is too thin and the parts contain parallel walls. The airbox on the right was scanned with the Creality Scan Raptor Pro months ago when I first got it. And this one has a shell thickness of 1.6 mm, while the one on the left has thickness of 3 mm. So if you want to know how I scan this part, you can check out my previous video. To be able to scan part like this successfully, your 3D scanner needs to be able to do a global marker and continuous scanning. Okay, let's take a look at the scan. You are going to see a blind spot from the 3D scanner because the object is blocking itself from the 3D scanner. So those blind spots has no surface data. So when you mesh the 3D scan, the software will try to fill the holes using the random surface, like in this part and in this part, as you can see here. Let me move this a bit, like this part and also this part. So you will never get a complete scan from a part like this because there's a limitation of the blind spot from the projector. See here, inside of the tube is not scanned, same as the one I made. So if you want to reproduce this part correctly, then you have to do the reverse engineering in CAD. So this is the cover side, and it will be the side that is going through the engine. So when the original part that you are going to reproduce is made from plastic, it's likely that you can 3D print that part and getting the same functionality, because the 3D printed filament has a similar property with the most automotive plastic part in both the strength and the stiffness. So when I reverse this part, I'm going to maintain the stiffener that the original designer provide. As you can see, there are stiffeners along the mounting flank to increase the stiffness when it compresses onto the air filter. And from the inside, there are 3 stiffeners, 1, 2, and 3. These stiffeners are for strengthen the part when you insert the air hose, so the wall will not flex too much. And there is also a partition inside of the air box, but it's sagging down. I don't know why it's sagging down like this. If they do this on purpose or if the part is deteriorate. The airbox also comes with the extrusion for attaching the other accessories like this one. So I will include it into the print. But this one is look like the inlet for the injected mold. So I will exclude this one and this one because I don't know what are they for. And some of the part doesn't have a clear information like this part, but I try to trace it and see if I can put that into the model. There is also 2 holders for the pipes. I can include that into the model as well. And if you look here, I will fill this a pocket with a solid because I don't have to make the thin stiffener wall like this. It's going to create a complication when you make a 3D print. So the top of the shell is made with the curved surface. So it's good for resistance of a negative pressure. And on the back side of the wall is also curved. This is the reason why Toyota, they don't put a lot of stiffener into their airbox. I like the Mitsubishi one that contain a lot of flat surface. See here, so that's why they need to add stiffener, because a flat surface has less resistance in the deflection. Viewer sent me only the mesh files, not a point cloud, so I need to convert this into the point cloud using the cloud compare. Okay, so I drop in the airbox files, just obj files is the mesh files. Okay, next I'm going to convert this mesh into a point cloud. Edit mesh sample points. Because this mesh has about 2 million faces, so I will use 2 million for the point number. It's 2 million, right? 2 million. Click on OK. So I'm going to delete the mesh. So now we have a point cloud. Let me change the color, light green color. Okay, so we have a point cloud, but it's the best to just use the original point cloud from the 3D scanner. So now I'm going to align this flat face here to the XY plane. Click on this 3-point alignment. 1, 2, and 3. Okay, now it's aligned. Next, I'm going to rotate it along the Z-axis. Move it to the edge of the monitor and try to rotate it. You can do a fine adjustment again in the CAD software. Okay, now let's check the quality of the scan. I don't see any visible seam line because the Raptor usually produce a high precision scan. There's no seam line anywhere, and if I make a cross section, a thin cross section, like 1 millimeter for the thickness, right? And if I look onto the sharpness of the line, you see that. Let me increase the dot size here. Okay, see this thin line? This line is less than 20 microns. That's the precision of the 3D scanner. You can see this line. So the lines that I'm going to use for tracing is very thin and sharp. See, there is no noise, no visible noise anywhere. This indicates the quality of the scan, and it will make reverse engineering much easier if you have a sharp and clean scan. Okay, here's in the Autodesk Inventor, and the approach that I'm going to use for modeling this part is by using a solid modeling. The most command that I will use is just simply extrude command. I will create a box like this, and I will start to shaping until the shape match the point cloud. So this is how I start, just using a rectangle box, and up to the point where I have a detail of the outer shell, I will use a shell command to create a thickness, because this airbox has a constant thickness of 3 millimeters. Okay, let me walk you through the process that I took to model this part. Okay, so here comes the most difficult part of this project, 3D printing. I'm gonna print this with ABS, and the first thing that you have to consider is the orientation of the object. So if I put it on the flat face like this, the curved part will need a lot of support and it's on the outside. And I probably need to do a lot of sanding and the surface quality won't be that good. So I need to turn it onto the side that require the minimum support. For me, I will use this corner because if I put this corner down to the build plate, this air hose is going to be in a lower position, so the support won't have to go along in the taller part. So I will face this face down to the build plate. Okay, this one. Alright, so I will print this part in this orientation. I'm going to enable the support and see how the support will be put in this object. The threshold angle is 30 degrees. So anything that below 70 degrees to the build plate will have a support, right? So I click on slice the plate, and this is a very important part because if you have a support failure, and this is 15 hours printing, you will lose a lot of time and also the filament. It's half a kilo of filament. Okay, let me show you how I make the support for this part. So I'm using a Creality slicer because I have a Creality printer, but it's quite similar to the Orca slicer. So what I do here, you can do that with the Orca slicer as well. I'm going to slide down to the build plate, first layer, and I'm going to move it up slowly. Okay, now you see this small part here. This part is isolated and it's very far from the main object. So it's going to take a lot of layers until it touches the main object. See here? This part like this is prone to the failure. This is the point that it will fall down from the support. See here? It cannot stay in this angle like this alone. So what I'm going to do is that I'm going to use the paint support function to add the support from this point to this point. What I have to do is just looking for the isolate part like this, like an island, and I will paint the support from that isolate part to the main part. So this will be the first one that will fail. And if I move up, okay, let's move and find the point of failure. Okay, now we have a second point. You see this one, it's floating in the air and it's quite far away from the main object. So it's going to take a long time for this part to touch the main object and increase the stability. There's second one popping up. So these two will fall down before it reaches the main object. See here, it's going to fall. This part is going to fall. So you need to paint the support from this point to this point so that the support will wrap around this little object and prevent it from falling. Okay, let's find the other part. There are 1, 2, 3 and 3 points already. Okay, so we have another one. You see here, that one is also very far from the main object. This part will fall. Okay, let's move to, okay, so now we have another one. 2 little guys here, they will fall. See, the contact area is very small. So what I have to do is just paint around that area to increase the support area. It can't just float like that in the air. Not possible. When it touches the main body, it can stay, but it will fail before it reaches the main body. Okay, these lips are also quite far from the main body. This part here, the contact area is very small. Okay, there's no other isolated part. Click on support painting. There's a few ways to paint it using the fill command. So I'm gonna paint this part, this face, and this entire face, this face. Okay, so this part will be paint as well, this part, and I probably paint this. I don't need to support the whole part, manually paint it. Okay, and this one I'm going to manually paint it. I only need this part. right? And this part I need a support entirely, and I'm going to add this part with the support painted. The filament weight is 426 grams, 15 hours, 24 minutes for printing. So there is no parts breaking from the support. About inside here, there's no breakage on the support. Let's remove it from the build plate. Quite a lot of support here. Okay, let's check quality of the print. On the front side it looks clean and there is no repairing required. On the top as well, quite smooth and clean. This side is okay. This side is okay. The issue is lying on the side with the support. But I can sand this. And for the inside, it looks really nice and clean. There is no flex. 3 millimeters wall thickness. It's quite stiff. If I insert the hose, pushing the hose, it's quite stiff. Okay, let me sand this with 400 grit sandpaper. Okay, here after sanding, it's smoother, but I still can see defect from the support. And it will be only this corner that has to be sanded. The rest of the airbox looks okay. And one thing I learned that this extension, the clips, it should be printed separately. I can make a dovetail joint, print it separately, and then put it back with the glue. That will make it easier for printing. And for the tube here, I think it should be printed together with the shell because we don't want any joint for air to leak. These are small parts here, can be printed separately. This one here too. Okay, so it's possible to make airbox with a 3D printer. I don't see why not. Okay, this will be a good looking angle. Thank you guys for watching. I'll see you in the next video.